Alright, hey guys, we're going to talk about 6.7 and 6.8 trigonometric equations today. Because this section is pretty long, I'm mainly going to focus on the ones that are most essential for you to know. And this video will still probably be a little bit longer than the others. So the first example is determine whether theta equals pi over 4 is a solution to the equation sine of theta equals 1/2. So pi over 4 we know is right here on our unit circle, so we're basically asking ourselves, does sine at pi over 4 equal 1/2? And the answer to that is no, because we know that the sine is square root of 2 over 2. Okay? Next, at pi over 6, the coordinates are square root of 3 over 2, 1/2. So the sine value there is 1/2, so the answer to that is yes. Okay? Alright, next one. Cosine of theta equals 1/2. Give the general formula for all solutions. Alright, so cosine is x, so we're only going to be looking at the right side. So that's going to happen right here and right here. And those places are pi over 3 and 5 pi over 3. Now the general formula, so that's just between 0 and 2 pi. So the general formula, I can always take pi over 3 plus 2 pi k, because 2 pi represents a full circle. Okay? So 2 pi k, where k exists as an integer. Remember that from when we, talked about graphing sine and cosine and all of that, and cosecant. Same thing with 5 pi over 3 plus 2 pi k, where k exists as an integer, because that will get me to the same spot on my unit circle. The last thing it asks me to do is list 8 of my solutions, so I already have 2 of them. Pi over 3 and 5 pi over 3. Alright, so I want to add 2 pi, so 1/3 plus 6/3 gives me 7 pi over 3. Okay, I can do it again. 7/3 plus 6/3 gives me 13 pi over 3. 13/3 plus 6/3 gives me 19 pi over 3. And again, 6/3 just represents that 2 pi. Alright, same thing down here. So 5/3 plus 6/3 gives me 11 pi over 3. 11/3 plus 6/3 gives me 17 pi over 3. And 17/3 plus 6/3 gives me, 23 pi over 3. And those are 8 of my solutions, and I kind of crossed those out, but it's okay. Okay, so those would be 8 of your solutions along with the general formula. Alright, next one we have a little bit more complicated equation where we have to actually do a little bit of algebra. So 2 sine of theta plus square root of 3. So the first thing I'm going to do is minus square root of 3 from both sides. So 2 sine of theta equals negative square root of 3. Then I'm going to divide by 2. So sine of theta equals negative square root of 3 over 2. Alright, so then I'm going to look on my unit circle, where does sine of theta equal negative square root of 3 over 2? Alright, so that's going to happen right here and right here on my unit circle. So I just have to figure out what those angles are. Notice because it's between 0 and 2 pi, I'm not looking for the general formula, I'm just looking for what those exact angles are. So that's going to be at, let's see, so we have 6, 6, 7, 6, 8, 6, so 4 pi over 3 and 5 pi over 3. Okay, so my final answer would just be 4 pi over 3 and 5 pi over 3. And those are your 2 solutions. Alright, we're going to skip ahead. The next one I'm going to do is on the back. It's the one that says 2 sine squared of theta. So I'm going to give you a second to get there. Alright, so this one, you notice is squared, so what I'm going to do is replace right here. I'm going to use u equals sine of theta. Again, you don't have to use u, I just generally use it. You'll see a lot of like u's in calculus. So u equals sine of theta. So wherever I see sine of theta, I'm going to replace it with u. So this becomes 2u squared minus 3u plus 1 equals 0. So now I have something that I can factor. So I'm going to factor again. You factor however you want. 2 up top, negative 3 on the bottom. Two numbers that multiply to 2 and add to negative 3 are negative 2 and negative 1. So 2u squared, 1, negative 2, negative 1, 2u, 1u, minus 1, minus 1, 2u minus 1, and u minus 1. So then I'm going to go back and I'm going to replace my sine of theta. So I have 2 sine of theta minus 1, and then sine of theta minus 1. So I'm going to set each of these equal to 0 because I know that my whole equation equals 0. And then I'm just going to solve. So this one ends up being sine of theta equals 1/2, and then sine of theta equals 1. Okay? Alright, so I need to find out where each of these things happen. So I'll start with sine of theta equals 1 because that one's probably the easiest. So sine of theta equals 1, where does y equal 1? That's at pi over 2. Next I have sine of theta equals 1/2, so that is at these two places on my unit circle. So that is going to be at pi over 6 and 5 pi over 6 on my unit circle. So my three answers are pi over 6, pi over 2, and 5 pi over 6 on my unit circle. Okay, so the big idea whenever you see something like that's squared, see if you can replace it with u, or you can do it with really whatever letter of the alphabet that you want. Okay? Alright, let's go to the next example. Alright, this one, if you try that same kind of idea that we did in the last one, you'll run into a problem because you notice we have cosine and we have sine squared. But this is where we want to use that identity that is my Pythagorean identity. So sine squared of theta plus cosine squared of theta equals 1. Okay? So with that identity there, we know that we can kind of manipulate it a little bit. And so I have a cosine, I can't do anything with that, but I can manipulate the sine squared. So sine squared of theta equals 1 minus cosine squared of theta. So I can rewrite that and get everything in terms of cosine. Because when I have everything, remember, when you have everything in one variable, I can do a lot more with that. So I'm going to rewrite this. 3 cosine of theta plus 3 equals 2, 1 minus cosine squared of theta. So anytime you can rewrite it in terms of all cosine or all sine, that's going to be your best friend. Alright, so now I can do a lot more with that. So I'm going to go ahead and distribute this. So I get 2 minus 2 cosine squared of theta. And I'm going to go ahead and get everything on one side. So add 2 cosine squared and minus 2. So 2 cosine squared of theta plus 3 cosine theta and then minus 2. So I get plus 1 equals 0. So all I did was move everything over to the left side. Okay, so I get something that looks very similar to my last example. 2u squared plus 3u plus 1 equals 0. When I go ahead and factor that, that factors into 2u plus 1 and u plus 1 equals 0. Now I need to go ahead and replace that with cosine of theta. So 2 cosine of theta plus 1 and cosine of theta plus 1 equals 0. Now I'm going to go ahead and set both of these equal to 0. And solve. So I want to know when cosine of theta equals negative 1/2 and when cosine of theta equals negative 1. That's what I'm looking for. Now obviously we've done a lot of algebra and math to get there, okay? So cosine of theta equals -1. That's when x equals -1, so that's going to be at pi. All right, now -1/2. So that's going to be at, let's see, so that will be right here and right here. So that's going to be at 1626646, so 2 pi over 3, 6667686, and 4 pi over 3. Okay, so my final answer ends up being 2 pi over 3, pi, and 4 pi over 3. Okay. All right, next one. So same kind of principle here. Remember from a couple of times ago, cosine of 2 theta, we have 3 different options for how to write it. Now, remember to help yourself out because cosine of theta, one of my options for how to rewrite cosine of 2 theta, I have an option for how to just write it with, I have an option that includes cosine of theta, and I want to try and get it with only one trig function in it. So I'm going to choose to rewrite cosine of theta as 2 cosine squared of theta minus 1. Okay, because I have that cosine of theta on the other side, I don't want to include sine anywhere. That's not going to help me out. So plus 3 equals 5 cosine of theta. All right, again, I'm going to get everything on one side. So 2 cosine squared of theta minus 5 cosine of theta to get everything on the left, plus 2 equals 0. Alright, so 2u squared minus 5u plus 2 equals 0 when I replace. So when I factor this, this turns into 2u minus 1 and, oops, u minus 2. Alright, so let's go ahead and go back and replace that with cosine of theta. So I get 2 cosine of theta minus 1 and cosine of theta minus 2 equals 0. So when I set each of these equal to 0, I get cosine of theta equals 1/2 and cosine of theta equals 2. Now I'm actually going to start on the right here with cosine of theta equals 2. Going back to the very beginning with math 3, we know that cosine of theta can only fall between -1 and +1. So I am not even going to worry about this guy. Cosine of theta will never equal 2. Okay, now cosine of theta equals 1/2. That's going to happen right here and right here on your unit circle. So this is where, again, it comes down to a lot of it is just knowing your unit circle. All right, so this is pi over 3. And this is 5 pi over 3. So my final answers are pi over 3 and 5 pi over 3. All right, next one. So cosine squared plus sine of theta equals 2. So again, I don't want multiple trig functions because that makes my life harder and I can't do it. So this cosine squared, I go back to my Pythagorean trig identity, and I know I can rewrite cosine squared as 1 minus sine squared of theta. So 1 minus sine squared of theta plus sine of theta equals 2. Alright, so I'm going to get everything on one side. So what I'm going to do here is I'm going to go ahead and get everything on the right side. So this is going to equal 0, and I'm going to add sine squared of theta, and minus this, and minus 1. Okay, so I get sine squared of theta minus sine of theta plus 1. Okay, so that turns into u squared minus u plus 1 equals 0. Now, if you notice, here that this ends up being, if you take the, if you do like b squared minus 4ac, so the discriminant, so negative b, so let's just do the discriminant, b squared minus 4ac. So 1 minus 4, 1, 1. This right here is negative. Okay, so therefore, since the discriminant is negative, there's no solution. Because this right here, sine squared minus sine of theta plus 1, will never equal 0. Okay, so therefore, this one, there's no solution. Alright, I have one more that I want to do, and that's the middle one on the back. Alright, solve the equation sine of theta plus cosine of theta equals 1. Okay, now this one's kind of just more of a conceptual understanding of the unit circle. The only time that this is going to happen is when one of them is either 0 and 1, or obviously like 1 and 0. Okay, that's the only time that this is going to work. Okay, when sine plus cosine equals 1. Okay, so we have to think about where on the unit circle is it either 0, 1 or 1, 0. Okay, so if we think about that, that's going to happen at these two places on the unit circle. So that is pi over 2. So that would be one solution. And then if you look at this, it says 0 is included and 2 pi is not. So therefore, we're going to define this point right here as 0. And again, that goes back to, it says in my interval, 0 is included in my interval and 2 pi is not included in my interval. So that point right there, which has the coordinate 1, 0, is called 0. Okay. Again, 2 pi would be a solution if it was included in my interval. Okay, so that kind of gives you a background on trig equations. Main idea is just to kind of get it all in terms of one trig equation. If you can do that, if you can factor, look for different ways to solve. Okay, and that's about it.